goods store or a sporting goods company has 3 stores in 3 towns. They want to build a distribution center so the distance from each store to the distribution is as close to equal as possible. Where should they build their distribution center? Should they build it like right here? Or right over here? Or right down here? Mr. Hodges, time to be done. You lose. Can't set the record. All right. It'd be nice if we had added distances on here. So now that I added distances, it can help me a little bit to find about the center. Boy, this is hard to find the center. If I only had a better way of doing it. Well, there is a better way of doing it, and we did it the other day. Okay? What we did the other day was we did construction. If I connect the 3 stores with a triangle, and I draw the perpendicular bisectors of each side, let's see how close I can get with this. So if I draw my, what we called the Jesus fish the other day, and I draw it here, and then I do the same thing to this side. Oh, I gotta go a little further probably. Right down here is my circumcenter, where if I draw a circle, it hits all 3 stores. So this point right down here should be about the same distance away from all 3 stores. So now if I drag this point down right there, oh, look at that. If we go just a little bit lower, everything's about 8.8, 8.899. They should build it about right there. Geez, we did those constructions the other day, and it actually makes sense to a real life application problem. That, hey, that would be a great place for a store if it's located between 3 spots. Okay, so we just did, it'll be fine. It's just when I tip it, then I'll tip it this way, and it'll go back again. Look at that. Okay, so right there, the circumcenter of the circle, the center of a circumscribed circle, is equal distance away from the 3 points of the triangle. So, let me go to here. Okay, we just did that. So, the circumcenter, the center, is an equal distance away from the 3 endpoints of the triangle, because you can see equal distance, equal distance, equal distance. Okay, that's what happens. So we have a bunch of vocab words in this section. So, when 3 or more lines intersect at one point, they're said to be concurrent, and the point where the lines intersect is called the point of concurrency. When 3 or more lines intersect at one point, the lines are concurrent. Yes. Well, yes. Because you were a little late. So when three or more lines intersect at one point, they're said to be concurrent. And where they intersect is called the point of concurrency. The circle that contains all three vertices of a triangle is called a circumscribed circle, and that's a construction that we did. The first four constructions on that worksheet we did the other day were for a circumscribed circle. The first four that we did were for a circumscribed circle. So the circle that contains all three vertices of a triangle is called a circumscribed circle. And there's a picture of a circumscribed circle. Did you get equidistant? It's the same distance from 2 points. So, when three lines come together, it's called and it's the point of concurrency of the three perpendicular bisectors. It's called the circumcenter. So the point of concurrency of the perpendicular bisectors of a triangle is the circumcenter. Okay. So that's this dot right here is the circumcenter. So the point of concurrency of the perpendicular bisectors here's one perpendicular bisector, here's another perpendicular bisector, and here's another perpendicular bisectors. Where all three of those meet is called the circumcenter. And the circumcenter is the same distance away from each of the vertices. Okay, you'll have to know that. So a city manager wants to place a new emergency siren so that it's the same distance from a school, a hospital, and a recreation center. Where should the siren be placed? Well, when you draw a triangle between the school, the rec center, and the hospital, it's kind of an obtuse triangle. So when you draw the perpendicular bisectors, and they draw theirs just a little different, they don't do the whole all the way through like I do. But the perpendicular bisectors meet here, outside of the triangle. But that's where the siren should be placed, so it's the same distance away from the school as the rec center and as the hospital. So if you draw perpendicular bisectors of a triangle, it's going to be equidistant from the vertices of the triangle. All right. So I want to find my perpendicular bisectors of this. Well, my perpendicular bisectors, a bisector means that it goes through the point halfway across. So what's the point halfway in between 0, 0 and 4, 0? Halfway between 0 and 4 is 2. So if I go perpendicular to this side at 2, There's one of my perpendicular bisectors. Okay? Then between 0 and 3, what's halfway between 0 and 3? 1.5. So if I go perpendicular to this line at 1.5, boom, that's where it should be. Where's that point? Well, it's at 2, 1.5. That's the ordered pair of the circumcenter. 2, 1.5. Because this is perpendicular to this line, this is perpendicular to this line, and it hits it at the midpoints. Okay? Now, if we talk angle bisectors, here's an angle bisector, here's an angle bisector, and here's an angle bisector. The three angle bisectors all meet at a point that is the same distance away from the sides, not the endpoints, because you can see this point is a long ways away from A, and it's not very far from C. So this point, where all the angle bisectors meet, is the same distance from each of the sides of the circle. So that's where the other day we made the inscribed circle. An inscribed circle is made from the angle bisectors. Okay? And it's the same distance away from each of the sides of the circle. So, an inscribed circle is the circle that intersects each side of the circle at exactly one point and has no points outside of the triangle. So that one's a little bit longer of a definition. The circle that intersects the side of each triangle at exactly one point and has no points outside the triangle. And the point of concurrency of the angle bisectors of a triangle is called the incenter. The point of concurrency of the angle bisectors is called the incenter. The incenter is the center of an inscribed circle. The circumcenter is the center of a circumscribed circle. Okay? Hopefully you get that. All right. So what kind of problems will we see with this? Well, it says if QP, this distance right here, is 3 times x plus 1, so if this one is 3 times x plus 1, and RP, this one right here, whoops, this one right here is 5x minus 3. And these are angle bisectors here. So this point is equidistant from the sides of the triangle. So what do you know about these two expressions? If they're equidistant, they are equal. So we set them equal to each other. 3 times x plus 1 equals 5x minus 3. What's my first step in solving this equation? What would be my first step, Alistair, solving this one? Distribute the 3. So 3x plus 3 equals 5x minus 3. Now, which variable do I move first? Which variable do I move first, Alistair? Or, excuse me. Morning, Caden. How are you doing, Caden? All right, Ember, which variable should I move first, the 3x or the 5x? The 3x, we want to subtract 3x first. So we get 3 equals 2x minus 3. Then what do we do to each side? Jade. Add 3. So 6 equals 2x. Then divide by 2. X equals 3. Okay? So x equals 3, but it says what's the radius of this circle? To figure that out, we got to stick 3 in there. What's 3 plus 1? 4 times 3 is 12 is the radius of the circle. All right. If JLP is 32 degrees, this one right here is 32 degrees, and JKL is 86 degrees, this whole thing is 86, then what's PJL? What's this one right here? Okay, this one takes a little thinking. If this whole thing is 86, this is 43 and this is 43. If this is 32, this is 32, which makes 68. So if this is 68 and this is 86, what's 68 plus 86 add up to? 154? Did I screw that up? Oh, well, Mr. Birschbach. Not very good at math. All right, that's 64. 64 and 86. Add up to 10, add to 150. So we have what left for that whole angle? What's the whole angle? This whole thing at J? 30 degrees. Now, if I want PJL, I want just half of it. Well, each half of this is 15. So PJL is 15. Okay? Angle bisector. Is that it? That is it. Okay? So, your second assignment is out there on Google Classroom, ready and waiting for you. I will post the video more for the people who are gone than the people who are here. But next time, be ready right at the start of class, because we're taking 2 quizzes and then we're covering another 2 sections. So we are doing lots and lots next Tuesday. So be ready for that.